on the exam, on this next unit exam, we got macros, we got carbs, we got fats, we got protein. I am going to ask, excuse me, I am going to ask one of those macros. I'm going to ask how digestion occurs. Okay. I'm either going to ask it in a specific location. And we have 3 locations, basically: mouth, stomach, small intestine. Okay. Now, when we talk about carbs, there's some stuff that happens a little bit, within the large intestine when it comes to fiber. But for the most part, those are the 3 major areas where magic is happening in terms of digestion. When we talk about absorption, the vast majority of absorption really happens in the small intestine. All right. There's a little bit that happens in the stomach, and we'll talk about that. It's alcohol mostly. But there's some other things that can be absorbed there. But for the most part, absorption is going to be happening really in the small intestine. All right. So I ask it a multitude of various different ways. Sometimes I ask specifically what is going on in a location, whether it be the mouth, the stomach, or the small intestine. Or I'm going to ask you to talk about digestion of this macronutrient. Okay. And again, mouth, where the food's going. Stomach and small intestine are the 3 major areas where magic is happening. So you've got to discuss those things. All right. So let's look at this. So this is going to force us to remember all the way back to unit 1, right? With the digestive system in chapter 4. For carbohydrate digestion, as all of these things, you put food in your mouth, right? In the mouth, we have salivary amylase, okay, is what is going to begin starch digestion. All right. We have multiple different types of amylase: intestinal amylase, pancreatic amylase. Again, the moniker in front tells us who secretes it. Okay, secreted by the salivary glands. So as long as the food is in your mouth, the salivary amylase is being secreted into it. As you mash up that food, there is mechanical digestion. So if you want to get in and talk about that, that's perfectly fine. I wouldn't fault you if you talked about it. But salivary amylase is the thing that I'm really looking for that is occurring in the mouth. Again, if you want to talk about teeth and mastication, fantastic, you can. Okay. And it's that mixing that allows the saliva to mix around with all the food stuff that you're eating. But this salivary amylase is acting on these starches in your food, in the carbs, okay, that you're consuming. Now, food does not stay here a whole hell of a long time, right? So, are we breaking down a substantial amount of starches here within the mouth? No. But does it begin? Yes. Will salivary amylase continue to work as it goes down the esophagus? Yes, it'll still kind of be working a little bit, breaking this long, complex molecule into smaller bits. But again, it's only about 10 inches, right? And it doesn't stay there for a really long period of time. Gravity's pulling that down. I got peristalsis. I got movement, magic. Get it into the stomach. So, a few minutes. Now it's in the stomach. As soon as this bolus, right, which one of the components is carbs, as soon as this carbohydrate blob reaches the stomach, it hits that acid. What do acids do? Destroy things, right? Destroys the enzyme. So soon after it enters, it plops into that acidic stomach content, destroys the enzyme, and really it stops working. All right. So here for carbohydrate digestion, the mouth. In the stomach, digestion of the carbohydrate of the starch stops. But what's happening here? Well, I still got mechanical digestion. Okay. So if you want to add, stomach and say mechanical digestion, I'm going to put shorthand mechanical digestion. Okay. Yeah, you could put that. Okay. Because that's really all that happens from a carbohydrate standpoint here in the stomach. All right. Those 3 muscular layers moving to kind of mush and mash this up. All right. Now, What about fiber? Fiber is carb, right? Complex carb. If there is a lot of fiber within this carbohydrate that you've eaten, it actually helps to slow the rate at which material exits the stomach. This is twofold. Well, one, we don't have enzymes for it, right? But really, the body wants to digest this thing. Okay? It wants to digest it. Okay, so it'll pull in all this water into the stomach. Hydrolysis, right? We're going to break this thing down, but we can't. And that's how fiber works to really give you this sense of satiety, to make you feel fuller. Okay, one, it slows the emptying down of the stomach, so food stays in there longer. Bolus food, whatever. The food stuff stays in there longer. But it's also going to fill up a little bit more as it's pulling in water into the stomach to try to break down this thing called fiber. It can't, right? So 2 reasons, okay? One, it slows the emptying of the stomach, so it slows the opening of that pyloric sphincter, and it pulls water into it, filling up the stomach a little bit more, and so you don't consume as much, which is fine for us adults, but if you're a child and you consume more than the normal amount of fiber for their age group, that can lead to not consuming enough calories. So that can lead to some malnutrition potentially in children. Fiber is important for them, but not an excessive amount of fiber. Okay? And when it comes to children with fiber, they're pretty damn close to what we need when it comes to fiber. I think teenagers, they're pretty comparable to our amount that we need to consume. Toddlers, preschool age, school age children, anything below, anything from 2 to 10, I believe, is the age range I'm discussing here. They have slightly less fiber, but we'll talk about that at the end of the semester when we start looking at children. So we come from the mouth with salivary amylase, mechanical digestion, okay, doing its magic to break down starch. And it's just breaking it down into smaller clumps. Stomach, enzyme gets destroyed, so we stop carbohydrate breakdown. And we're mixing the contents, fiber, slowing it down, stays in the stomach a little bit longer. Open up that pyloric sphincter and we enter into the small intestine. This is the major site for carb digestion and absorption, okay? This is where we do a lot of legwork. And as you can see, there are a number of various different enzymes, 4 of them. 1, 2, 3, 4. All of them have, well, the first one that gets secreted is an amylase, okay? We're still talking about starches here, okay? We're still talking about something big, all right? Again, like I said, food doesn't stay here long in the mouth, right? So we're only getting a little bit of breakdown, a little bit of cutting up that huge complex starch molecule. Pancreas secretes its own amylase, okay? It's underlined, it's probably important. Excuse me. This helps to continue that breakdown of starches into specifically maltose. I say this is the first one that gets secreted because in the duodenum, there's not a huge amount of absorption occurring. Okay? There's not a huge amount of absorption occurring of really anything. Okay? There's a little bit, but not a whole hell of a lot. That's in the second part, the jejunum. It's where we have the vast majority of our absorption occurring. So we have a lot of enzymatic activity being thrown in. And the first one is from the pancreas. Pancreas and the gallbladder doing its thing, but the gallbladder is not involved at this point because we're just talking about carbs. That sphincter of Oddi opens up and the pancreas releases its contents. Specifically, pancreatic amylase is what we're talking about here. It helps to break down that complex starch molecule into maltose. Now, I have the pancreas, and then I have all of these enterocytes. And again, this is just a fancy name for intestinal cell. Okay, so I'll call it the enterocyte or the intestinal cell. It's the same thing. You can call them either one. okay, on a short answer question or an essay question, whatever. So as you can see, I have the intestinal cells secreting enzymes, those brush border enzymes, right? From those little microvilli, those little bitty hairs. They secrete enzymes as well. Maltase, sucrase, lactase. What are all of these? These are all disaccharides, right? What do we ultimately want to do in the body? We break down something complex and get it to their basic component parts, okay? Monosaccharides are simple sugars. So we have various disaccharides, one for each one. And it helps to break these down, split them up, and get them into their monosaccharides. Okay. We try to get them to our monosaccharides. What are those monosaccharides? Glucose, fructose, galactose. So if you consume a lot of foods that have get me a lot of maltose, you can see we get a whole buttload of glucose. Right? Sucrose and lactose, half of that amount. Excuse me, goodness. Once we've broken these things down, now I can absorb them. Okay? Glucose, fructose, galactose, I can easily absorb these things. Can a cell absorb a disaccharide? It can, okay? There are some mechanisms. It does cause a little bit of inflammation within the cells. Okay? So you can have some issue. It's not very effective at all of that absorption, okay? Very effective at absorbing all of our monosaccharides right here, okay? But can they do it? Sure. If you have a slight lack of enzymes like lactose, right? Lactose intolerant. Can you absorb some? You can, but again, it causes a lot of swelling and inflammation down in there. When we absorb these things, absorption, again, all the magic is happening in the small intestine. And it's going to be shockingly similar for all of these monosaccharides, or I'm sorry, for all of these macronutrients. All right. As you can kind of see, it varies. The mechanism, we have active transport mechanisms. Remember, this requires ATP. This requires energy. Fructose can be absorbed by facilitated diffusion. It goes down its concentration gradient. Doesn't require energy. All of these monosaccharides, all of them, as you can see from this fantastic little picture here, go through that hepatic portal system, get delivered to the liver. Okay. Here, the liver does a few different things. It will convert fructose and galactose into something that can be utilized. It will release glucose back into the bloodstream, so it can be delivered to all the cells. It can be made into glycogen, okay? Remember, that's your storage form. Okay. Once we fill up our stores, we turn it into fat. Okay. So we can make it either into glycogen, or we can turn it into fat. All right. We turn it into fat after we've filled all of our stores. Stores in our liver, stores in our muscles, okay, skeletal muscles. All right. Excuse me. Once we've filled those stores, we convert it into fat. It's released into the bloodstream for energy use, either turning glycogen into glucose again, and we'll talk about that when we talk about regulating levels of sugar within the blood. Or glucose just being dumped right back in here, and it gets delivered throughout the body, goes to the heart pumps it out, goes throughout the entire system, and we deliver the goods. Okay. And remember, the primary goal of carbohydrates is to provide energy. It's its primary goal. The brain, red blood cells, love glucose. Okay. That's why it's so good. That's why carbs are so fantastic. Okay? Because they supply all that energy. And your brain needs a ton of stuff, ton of energy. We have a huge blood supply going to the brain, supplying all of these sugars to help fund all that activity up there. And there's a lot of it at any given time. Fiber during this whole process, again, we don't break it down. Okay? Gets to the bacteria there within the large intestine, and they will start to chew up on it. Okay, they will break it down. They will utilize a little of it. They're not going to break it down into their component parts. Okay, try to get all the way down to a monosaccharide, but they will break it down a little bit and utilize the sugars that get broken off, and they will utilize it to make energy for them. Okay, helps keep the good bacteria growing, helps keep the bad bacteria at bay. And again, that's the stuff that we can't digest. Okay. There's also insoluble fiber. Insoluble fiber helps to, give you that fantastic little soft poop. All right. This leads us to what they refer to these fibers or these starches. I'm sorry. They refer to these starches that have a lot of fiber in them as resistant starches. When you think of resistant starches, you can think of them functioning like a soluble fiber. Okay, so if you want to act like a soluble fiber, yeah. Okay. So they act like a soluble fiber. Again, they're not broken down, but they give all of the kind of the health benefits that we associate with any dietary fiber. Improved insulin sensitivity, lowers blood sugar levels, just because it gets caught within the fiber mesh, okay? And we can't absorb it into the blood. So that means it's just going to pass out through the bowels. Reduced appetite, obviously, because it's filling you up. Feeds the gut bacteria, reduces polyps, cancerous polyps there within the large intestine, reduces risk of colorectal cancers. So there's a lot of fantastic benefits for this resistant starch, for fiber. Here is a nice little fantastic kind of overview of it, summary, if you will. Again, mouth, stomach, small intestine. Those are the three major areas in which magic is happening. You can put large intestine in there a little bit if you wanted to talk about carbs. Again, if I said from stem to stern, you would include large intestine just because of fiber. But I mean, if I asked about digestion, 3 areas. If I'm asking about absorption and where it's going to go, then the liver gets involved there. Okay, whoops. Okay, absorption. Nothing really happens in the rectum. I honestly don't know why it's there, listed there. Okay, but really nothing happens in the rectum. You're just holding it until you have a bowel movement. That's it. So there's really nothing to discuss there, unless you want to discuss poop, which who doesn't want